All right, good afternoon. We'll start the next session in the Security, Identity, and Policy track. With us is Miguel Martinez. Miguel is a contributor to Helm and Monocular. Is that right? Mm-hmm. Like a binocular, but...
Yeah, but like a single one.
But only one lens. Yeah. He also works on KubeApps, which is an open source dashboard for Kubernetes. And with that, I'll hand it over to Miguel. Sorry.
Hello, everyone. I'm actually impressed by how many people are interested in authentication at 3 p.m. It is awesome. So I'm Miguel. That photo actually is from a happy day, the day that I got my one wheel, which is kind of like that skateboard. I like it a lot. Actually, my wife is mad at me because she says that I take more pictures of that thing than anything else. But I don't know. I don't understand. I actually disagree because I also take pictures of my wife. I don't know. Anyway, so I'm software engineer at Bitnami. I am, as he mentioned, I'm core contributor at KubeApps, application dashboard for Kubernetes. Monocular, which is the engine behind Helm Hub, and Helm itself. So the agenda is very simple. The agenda is very straightforward. It's just I'm going to explain the problem that we ran into, give you a couple of takeaways of our journey implementing OIDC, and all the challenges that we ran into. And then I'm going to show you a couple of workarounds to basically bypass those limitations. So KubeApps is one of the projects I contribute to, and it's an application dashboard for Kubernetes. In other words, it's a web user interface that you install in your cluster, and at that point, you can install, or you can find, browse, and install and manage applications there. But the first thing that a user needs to do is to provide their Kubernetes credentials. And by that time, the only way to do that was by providing their Kubernetes service account tokens. And that means that somebody needs to go to the cluster, either the user or a cluster operator, find that token, and provide it. And that was an adoption barrier. And because configuring that token and configuring RBAC was actually pretty hard for the kind of users that we are targeting, that was an adoption barrier as well for security practices. They were even sharing the tokens. So we asked the community, and the answer was, please implement single sign-on here. So we quickly realized that the problem that we're running into, we're not the only ones. This applies to every single application that wants to offer authentication via single sign-on. And that application talks to the Kubernetes API server on behalf of the user. And that's the case for KubeApps, but it's also the Kubernetes Dashboard, and it's also KubeControl that we use every day. So looking into the scope of the problem, we realized that actually our problem is more associated to authentication, and also that we only care about humans. In our case, we just care about users that sign up in KubeApps in our case. And most importantly, we want a solution that works everywhere. So we took a look at the state of the authentication in Kubernetes. I left out some other solutions, but we basically took the main ones and created 4 categories. The first one is how easy it is to self-service those kind of credentials. Can you do it by yourself? Do you need the intervention of a cluster operator? Then is there any built-in rotation for those tokens, for those credentials? And what about revoking those credentials? How easy is it? And then the user experience once you have set up those credentials. So the first one is our client certs. And client certs, at least in our experience, require our SRE team or cluster operation team to verify who I was, craft those credentials, either manually or in an automated way, and then send them over securely. So self-service wasn't an option in our case. Rotating and revoking, it wasn't great either. Actually, in this case, sometimes if you want to revoke a single certificate, you might actually end up revoking all the users that use the same certificate authority, for example. And then user experience was fine. Once you set it up in your kubeconfig, it was fine. Then we got tokens, which can be either service accounts or static tokens next to the API server. And self-service is the same issue. But then rotation and revocation actually got better because you can rotate that thing. You can revoke and rotate programmatically. and a single user. Basic auth was it's very similar to the token, and then we got single sign-on. So single sign-on, once you set it up, once the cluster operator sets it up, you got self-service in most cases. It has built-in rotation via refresh tokens, and then revocation has a caveat because the token might have a lifespan, so during that period it might be tricky. By user experience, actually, we put it in green just because it's not only useful for users, it's good for users, it's also for cluster operators. So zooming in a little bit on why single sign-on on Kubernetes, for users, it's kind of like a no-brainer. They use it every day, they connect with Facebook, GitHub, with all these providers, and they don't want to have an additional set of credentials. And they also like the instant gratification of signing up and start using it right away. But then for cluster operators, which I think is more interesting, is that they don't need to generate or transfer credentials anymore. They don't need to care, about rotation or revoking those credentials, because that gets delegated to a third-party identity provider. And some of those identity providers even support advanced features like groups and scopes. So we started looking into, let's implement this. It seems the right thing, and that's what the users are asking for. And reading the documentation, I saw that Kubernetes already supports single sign-on via OpenID Connect. But what's the difference between OpenID Connect and auth2? I honestly didn't know the difference. So OpenID Connect is an identity layer. This is its official description. It's an identity layer on top of the auth2 authorization protocol. And to understand a little bit better, I created this diagram on the right side, which is an oversimplified version of the flow, and which we have 3 actors. Actually, there are kind of 4. The user and client, the authentication provider, and the resource that the client wants to access to. The first step will be the user will be redirected to the authentication provider saying, can you please grant access to this client to this kind of resources via the scope? And as a result, you will get an access token. The client will get an access token that then they can use to access the protected resource. And I said that auth2 is an authorization protocol. It's not an authentication protocol, but actually there are solutions out there that implemented authentication on top of it by creating basically user info endpoints that are treated like any other protected resource, which are the 2 lines down there. So what's OpenID? OpenID Connect. OpenID Connect in practice means that there is one more scope that you pass, and as a result, you get an ID token. And that ID token contains all the information for the user in a standardized and crypto-signed way. And that format is it's called JSON Web Token. And as a side effect of having all the information already in the ID token, we don't need, or whoever is implementing this flow, we don't need to have a user info endpoint anymore. So it simplifies things. To understand how the validation, how the verification of this token works, we're going to actually think about a real-world example. And that example is basically me traveling to the US. The first thing I need is to go to an identity provider, which will be the European Union or Spain in my case, and they will verify my identity, and they will craft the passport. The passport is the identity, is the bearer identity I need to take with me at all times. When I land to the US, they will take my passport, and they will check, is it from a trusted source? They will say, sure. We still accept Spanish passports. Hasn't been tampered with. They will check if it's an e-passport, or they will check that no pages have been broken or whatever, and it is not expired. And the key takeaway here is that US Customs, in theory, doesn't contact Spain for every single Spaniard that goes to the border. There is a mechanism already in place to validate those passports. If we extrapolate this to Kubernetes, it's basically the same thing. We got a set of identity providers that can be either managed or on-prem, like managed like Active Directory or Google accounts, or self-hosted like Dex or Keycloak, and then there is not a passport. What we have instead is the ID token that I mentioned before, which is a JSON Web Token. The JSON Web Token has 3 parts. A header that tells you what kind of signature it has, a payload that contains who you are, who provisioned this token, who is the audience, and when does it expire, among other things. And all this information is stored, they're called claims. But the most important part of this token is a signature, which will be used on the relying party end, which will be the Kubernetes API server in our case, to check if it has been tampered with. They will use the signature plus the public key, and they will verify that nobody has changed the token. But they will also check if it's from a trusted source via the issuer claim. They will also check that I am the receiver via the audience, hasn't expired, so on and so forth. So how do you configure this in Kubernetes? It is built in. You just need to use a set of flags. The most important ones are the 2 first ones, in which you say, what's the identity provider that you want to trust, and what client should be in the issuer part. And then there are two optional flags that basically what are saying is how to extract what information you want to extract from the token. Once you configure the API server with these flags, you can use ID tokens via the authorization bearer token. So going back to the problem statement, we want an application that offers single sign-on and talks directly. That application wants to talk to the Kubernetes API server. So how do we solve that? The first solution that we can think of is we can put a proxy, which is the green box, in front of your application or between your application and the Kubernetes API that will basically be configured exactly the same way that the Kubernetes API is in terms of OIDC, identity provider settings. And this proxy will be in charge of enforcing authentication, basically capturing the user, doing all the auth dance, coming back, getting the token, exchange it, refreshing it, and what's more important, it will inject the headers. It will inject a new set of headers upstream. So the API server will understand the new, the forwarded calls. So my first demo is going to be configuring single sign-on on top of the Kubernetes Dashboard by adding this proxy that I just showed, and I'm also configuring the API server. And because my success ratio in demos is about 5%, I'm going to play a video. OK, so we have Minikube, and we have the Kubernetes Dashboard installed. And the first thing that the Kubernetes Dashboard is going to ask you is, who are you, basically, because it needs to interact on your behalf. And the goal of this demo, or this exercise, is to remove this page and offer single sign-on instead. So we're going to install a proxy, and that proxy, one of the things we're going to do is actually inject a new set of headers, as I said. And to understand it a little bit better, we're going to do first the exercise by using this echo server, which is just a very simple web server that exposes the headers that are injected. So we have the echo server running. And what we're going to do next is to install the proxy. So the proxy I'm going to be using is called Keycloak Gatekeeper. You can use auth2 proxy, and there are others. But all of them work the same way. You configure the OIDC settings to say what's the identity provider that you want to trust. And then you're going to set an upstream URL, which all the requests are going to be upstream to. So if you try to access now the dashboard, the echo server, you get intercepted by the proxy, which is one of their functions. And now we see the echo server with way more information. It contains information like who I am, my email address, my name, and also a token. And what's more important, it has an authorization header that, as I said, is going to be injected in every request. So let's take a look at the token, because it should be a JSON Web Token. So we go to jwt.io, and here we can decode the token. So we're decoding the token now, and we can see that has been issued by accounts.google.com as expected. It contains my information, and it will say that it expires in 1 hour. So let's actually try to hit the API server with this token. I'm doing a call to the API server, and it says 401. This is expected. The API server doesn't understand this token yet. So the next thing that we need to do, the missing piece here, is configuring the API server. And this is trivial. This is doable in Minikube because you can actually pass extra config flags. So what we're doing here is actually reconfiguring Minikube by setting the same issuer URL and client ID that the proxy has. That way, the tokens generated by the proxy will be understood by the API server. So once this finishes, we can do a call again, and it should work. OK, so we have now the API server that understands ID tokens generated by the proxy. So the last step is just to put another instance of the proxy in front of the dashboard. And that's what we're doing there. Just moving forward. So it is exposed on the dashboard OIDC.minikube.net. Self-signed certificate. So we get intercepted. That's good. But this time, this should work. And as we can see, now the dashboard says, authenticated with the auth headers, and this is because also the dashboard has built-in functionality to read this token that has been injected by the proxy. So we went from an experience that required adding manually your credentials to basically getting access automatically to the dashboard via single sign-on. OK. So that was good. But that doesn't work everywhere. One of the conditions is this needs to work everywhere. And in order to make it work, as we saw, we need to modify the API server. And in many cases, we cannot do that. And actually, in many cases, we might not even want to do it. So regarding modifying the API server, we look into different distributions. And in some managed services, that actually can be tricky. In cases like GKE or EKS, this actually might have changed already because it changes every day. But GKE and EKS, you cannot modify those flags. In AKS and OKE, you can do it, but only selecting their specific identity providers. So this is actually the biggest problem that you might run into. Another another issue is that in Kubernetes, you can authenticate you can reference a user not only by its user, but also by its group. And the good news is that you can actually reference or take information from inside the token and map it to internal reference in RBAC. And you can do it by the flag that I put down there. But news are that, as always, this doesn't work everywhere either. So you need to make sure that you choose the right one. OK, so we know that if we modify the API server, this is easy. It's built in. This is great. But how do we do it if we cannot make those changes? So we looked into a couple of workarounds. Call it workarounds, hacks, whatever. But the idea is that this was kind of like it was the one that made sense at the beginning because the dashboard already supports service account tokens. KubeApps also supports service account tokens. So what if we have some kind of like system that will take the ID token, it will do the verification required, and extract the claims. And on the other side, you will get a service account token. That was kind of like a no-brainer. And to do that, we could actually rely on some Kubernetes primitive, like create a controller that will interface using an account CRD and all that good stuff. And even though this is actually cool, this is difficult. This was very difficult. So we looked into another solution, which is Kubernetes impersonation. Impersonation is a feature in Kubernetes that is built in. and basically allows any user to act on behalf of another one. So you can do things like kubectl, get boss as full user, and then on the API side, on the API server side, a set of like authorization checks will happen. The first one is, can the impersonator user impersonate the full user? Sure. And then, can the full user access pods? Because that was the initial command. And you might think, this is kind of like, impersonation is kind of dangerous because you might actually have a user that has God mode or sudo. You can limit it. You can actually make the impersonator only impersonate specific groups. So in some way, you can restrict that. The interesting part about impersonation is that actually using it is not different. You just need to pass a new set of headers. There are two new headers, impersonate user, which is required, and impersonate group, which is optional. And something to note is that the authorization header this time is not from the user. It is from the impersonator. So this is a difference. So by knowing this, we can just put up another proxy, and we're going to have two proxies, that will take the ID token, do the verification, and just on the other end, inject those new modified authorization header and inject those two new headers. And the way that we can set it up is we can put it between our app and the Kubernetes API server. And if you see how the flow will work is the user will enter in your application. It will be intercepted by the first proxy, the one that will generate the token for you. At that point, your application will have a token, which the API server doesn't understand and doesn't care. But your application will think that it's talking to the Kubernetes API directly, but it is not. It's actually going through that proxy, which is translating this ID token that the API server doesn't care and doesn't understand onto something that will actually care and it will work. And if you notice, there is no line between the Kubernetes API and the OIDC identity provider. We're basically extracting the logic, all the verification that will happen in the Kubernetes API to our own piece of software, kind of like our own middleware. So this is going to be the second demo. The second demo is exactly the same thing. We're going to take Kubernetes Dashboard, and we're going to add single sign-on. The main difference is that here we cannot modify the API server. We're running in GKE, and we're going to use impersonation instead. Okay, so I have running in GKE, I have running the dashboard behind the first proxy. So we get intercepted again, but this time doesn't work. So we can see that there is a token. What we're going to do is actually, because I don't trust software in general, let's actually do a call directly to the API server. So we're going to use this token to try to talk to the API server, as we did in the first demo. So we're calling the GKE API server here, and we get 401. OK, so confirm this doesn't work. So what we're going to do next is to add a new proxy, this impersonation proxy. And the good news are that actually it already exists. Our friends from Jetstack have already built one. This is awesome. And it does what we need. You configure it to trust an identity provider. They will take an ID token. It will do all the verifications that the API server actually will do, and inject the new headers, the new impersonation headers, proxying to the API server. So I have it running. And what we're going to do now is let's actually call the API server with the same token, but through the proxy to see what happens. So I'm port forwarding the port, the proxy. I'm doing a call through localhost this time. Remember, the first one failed, and this one is going through the proxy. So it seems that it worked. Let's take a look at the logs. So looking at the impersonation proxy, and I know this is very verbose, because in debug. But what we're going to see here is we're going to see that there is a new header called impersonate user with Miguel at Bitnami.com that was extracted by this proxy from Jetstack. And the other thing that it did was to pass the authorization header, which we're going to actually introspect now to see what it has inside. So we're going to JSON webtoken.io like we did before, and we are decoding it. So what we can see here is that this token doesn't contain any information about me as a user. It's basically has been issued by a service account, and it's actually the user that represents is the service account default in the OIDC proxy. So this is the impersonator, and the impersonator has been configured to be able to impersonate my account. Okay, so we have a proxy that seems to work. So next, we just need to take the Kubernetes dashboard and trick it. We're going to actually make it think that it's talking to the API server, but it's going to be talking through the proxy, and you can do that by just overriding that environment variable. You also need to override some certificates to do the client server verification. So I have it running under dashboard impersonation, Kubernetes, whatever, and then you get intercepted by the first proxy. We have seen that before, but now it works. The dashboard detects that, okay, it got some authorization header, but this now is actually responding. The API server is OK with it. So let's actually take a look at the logs. So in the logs, what we're going to see is that there is a call to API v1 default services, which is the page that I'm seeing in the dashboard right now. And it's impersonating my user. And just a quick note, this also works because I have a cluster or role binding for Miguel at Bitnami.com that I already set up. OK, so some thoughts. Single sign-on in Kubernetes can be vendor locked, can be challenging. But the good thing is that we can actually work around it. We can use Kubernetes primitives and just knowing where to put them. You can offer a single sign-on experience that works everywhere. If you want to learn more, we wrote an in-depth document about all these workarounds that we did there. We also touch all the authorization part that I actually left out in this case. I also recommend to take a look at the Kubernetes talk from Joel from Pusher. Check out the proxy that I used for my second demo from Jetstack. It's awesome. And you can find the files, the demo files that my colleague Annan helped me with. And that's everything I got.
All right, who's got questions? We have time. Yes.
How do you manage the HTTP? So in this impersonation setup, how does the proxy manage HTTP streaming requests like kubectl exec or kubectl logs?
I honestly don't know. I haven't. You mean like doing like an exec, for example, through the proxy? I don't know. I don't know how we'll do it. That would be actually a good thing to check.
So I have two questions actually. First one is, how does MFA get into all this? And the second one is there any ID or something that correlates the impersonator with the user, so I can track down what every single user does? Because because I want to see what has been done by whom.
So multi-factor auth, I believe that that's on the identity provider side. So before you actually get back to the final auth callback, that will, basically it will not affect on our end. So it shouldn't be a problem. Regarding the identity, so you are talking about some kind of auditing on the side of who is impersonating whom. I mean, the impersonator in this case is a single one, right? So if you actually go back to the other, let me go back. Yeah. So this one, for example, for auditing is actually much, much better because you will have all those CRDs that you will actually be able to check who signed up, when, and when that token was created, and so on and so forth. On the other side, you have that issue that the impersonator is a single one. So how do you know that? Logs? I don't know. You can always put something, some kind of like sidecar that will create some kind of logs anywhere, but I don't know.
So I have also a question. So as I understand, as long as you are using web browser, so for example, you log into web console, it's really simple and seamless. You just basically go to a page and you get signed on automatically. But if you are going through command line, you still have to go to web browser, obtain the token, and then copy it manually to the command line.
So I think that I believe that when you have a command line tool, what will happen is some kind of like local web server will appear, and then the callback from the auth tool will go to that local port.
Okay.
And I believe that you don't need to copy the token in that case. Your program should be smart enough to receive that request.
Yeah, so I just want to explain. I asked this because we have implemented a similar solution, but it's a very particular case. So I just want to know if there's any general solution for that.
Can you hand it that way?
Okay, thank you.
Of course.
Okay, so first you can use the client credentials flow to don't use MFA at all, and you get a Joe token, so you can use it for service-to-service communication from the command line. So question, does this work with EKS also? Because, so it doesn't allow you to modify the OpenID Connect flags on the API server, and it forces you to use YAML roles. So basically you should kind of impersonate using a YAML role. Is it possible to use this proxy on EKS also?
It should be able, yeah, it should work.
Okay, and another short one. Does it have a breaking glass? Because on the API server, for example, I can have multiple authentication modules, and if the identity provider goes down, I want to use the certificates or something else. Is it possible to have a break glass with it?
It should. Thanks.
Okay,
Anyone else? All right, let's give another round of applause to Miguel.
Thank you.